Hello, everybody, and welcome to the first talk of day 2 of the Work Components Remote Conference. First up, we've got Trey Shugart with The Eternal Sunshine of the Biased Mind. So a very special thank you to Trey because he's giving his talk all the way from Sydney in Australia, and I think it's about 2 a.m. for you, is it right?
Yep.
Yeah, so thank you ever so much for taking the time and staying awake to speak to us. So we really appreciate that. And on that note, I'll get out of your way and over.
Awesome. That's true. I never sleep. All right. So go back to one slide. I'm Trey. As Leon said, I'm going to talk to you a bit about bias and how it affects the choices and decisions that people make in our industry. If you want to check out some of the links or follow along, you can go to the URL shown there. That won't actually follow along with as I go through the slides, but you can feel free to go through them and whatever. For the first part of the talk, I'm going to focus on some forms of cognitive bias and touch on how bias relates to our industry and our everyday lives, which will help give context to the rest of the talk. So to start off with, let's define bias. Bias is an inclination to hold a partial perspective, often accompanied by a refusal to consider alternative points of view. And more specifically, which I'm going to focus on, a cognitive bias is a shortcut in thinking that can sometimes lead to errors in judgment, but not always. A lot of you have probably seen this illusion before. Depending on how you interpret it, you may see an old woman looking downward or a young woman looking over her shoulder to the right. And bias is a really funny thing because you could be looking at the same set of facts and see different things based on your perspective and past experiences. We see bias every day, at the grocery store, on TV, politics. We definitely see it in politics. Bias is what keeps us from getting run over when we cross the street. It fills in the blanks when we're skimming through a lengthy blog post and don't have time to read every sentence, and it gets us fed. And the biases may offer shortcuts in making quick decisions. You may have made in that blog post that was imperative in making a recent decision in your tech stack. You may have gotten food poisoning because you misread the expiry date label on your chicken wings that you ate last night, or whatever. You will never be able to completely remove bias. And though bias gets a bad rap, it's the reason we can make quick decisions. Without it, you'd have to make precise calculations about every little thing that you do, every time that you do it. We also see it every day in our industry. Tabs versus spaces, object-oriented programming versus functional reactive programming, TypeScript versus Flow, web components versus whatever. It seems like everything is constantly at odds with each other. It's not always that way, but we love nothing more than to jump at an opportunity to have an opinion. Often people listen to respond rather than to learn. I was reading this article the other day written by a programmer named Sam Koblensky, and a couple excerpts from early on in the post caught my eye. He first says, "We argued because we feel so emotionally committed to our case, but there is no objectively right answer. Most, if not all of us, have argued for or against something. Many of us do it with passion, and I believe the statement to unfortunately be true for many arguments. However, if we can try and identify and mitigate our own bias, then we will be more effective in making objective decisions moving forward." Says, our biases come from, sorry, that's what I said. The thing that the programmer grew to despise may not have been directly responsible for the failure, but it was there and it was noticed. Our biases come from experience, and some biases are correctly linked, and some may be the result of an indirect phenomenon called illusory correlation, which is when a relationship between variables is perceived but doesn't actually exist. This quote describes a developer who has a negative experience with something. In a different scenario, they could have had a positive experience. Either way, that developer's predisposition to the subject matter is likely to end up being biased by their experience with it. For positive experiences, this is called the halo effect, and for negative, the reverse halo effect, double effect, or points effect. I'd venture to say that the halo effect and its counterpart play a major part in how many of us perceive libraries and frameworks. But what happens when you're presented with factual evidence to counter an experience? Your beliefs may persist. It could be for many reasons, but the fact that this happens can be described by belief perseverance, or the continued influence effect. And even after a correction has been made, misinformation can continue to influence the inferences that you generate. Related to this is conservatism, or belief revision, meaning the effort to revise your beliefs based on your facts is insufficient, and your previous beliefs will continue to influence the choices that you make and how you perceive information that is presented to you. In my opinion, probably one of the more important types of cognitive biases is the bias blind spot. It's the ability to recognize the bias. And I've always been interested in psychology. I did quite a bit of studying in preparation for this talk. And it got me really excited, and I found myself trying to call out biases, discussions and conversations. And while it's sort of obvious now, it wasn't very productive. I was totally that guy. In my experience, I've found that I can recognize my own bias. If I do that, I can make myself less subjective. I end up making better decisions while having more positive interactions with others. I've also found that objectivity can be contagious, where others may become more objective if they see other people being objective. I've seen subjectivity have the inverse effect. And surely there's a bias for that, but I have yet to figure out what it's called. Some of this slide might be cut off a little bit, but it's just an XKCD comment that I found relevant to confirmation bias. So I'm just going to quickly go through some of the types of bias before moving on. And I'll try and scroll down through some of these comments just so you can read them. Probably one of the more well-known types of cognitive biases is confirmation bias. For example, since I support web components, I am more likely to search for and interpret information about web components in a way that supports my pre-existing beliefs about them. And if you don't get to read all these, you can just go back through the slides and follow along. The bandwagon effect is when the adoption rate of something increases, the more it is adopted by others. This is basically GitHub stars in a nutshell. A friend of mine asked me, and I suggested he use Preact. I've previously suggested he use web components, and he dismissed that as well. And so although this is indicative of other biases, he quickly dismissed it and chose React instead due to popularity. The choice supportive bias is an interesting type of bias. When looking back on a choice, it's when you downplay the faults or highlight the advantages of the option that you chose while possibly doing the inverse for the option you didn't choose. You might say sometimes, well, look at the bright side, as to downplay the negative effects of a choice. The less you do this, the more you'll be able to learn from your past experiences. I heard about the Dunning-Kruger effect long before I knew what it was. And it's basically every Facebook comment thread ever. Anything you can put armchair before describes one aspect of this, which is when you overestimate your own abilities in relation to others. The other aspect of this is when you underestimate yourself in the same way, which is very similar to imposter syndrome. The last one I want to call out is the illusory truth effect, because this is how misinformation spreads. It's very prevalent in contemporary politics, but also very much alive in our industry. You may have heard the expression, the dom is slow, or that it's too bloated. This is a result of it being asserted many times without clear context around it, and since being debunked. The thing about bias is nobody is immune to it. Your dog, you, your boss, and that thought leader you idolize, they're all subject to it, even this talk. Probably especially this talk. The most objective people who are extremely well-versed in a subject can suffer from a bias that's called the curse of knowledge, which is when someone communicating with others unknowingly assumes that they have the background to understand the subject matter. And it's at this point you might be asking what this has to do with web components. That's a very good question, and it's one that I'm going to spend the rest of the talk trying to address. I'm first going to talk about our story using web components at Atlassian. I'm in the Atlassian office right now in Sydney. And and the eventual outcome and the reasons for that outcome. Then, and by no means am I a saint, I'll try and call out a few things working for me that I think we can all do to be better people at work, in programming communities, and around the world. So this is probably a good time for me to reveal my bias, as it will help set the stage for the rest of the talk. I totally dig web components. It's really, really nice to see an essential piece of the platform finally come to fruition. I'm also a very vocal member in the web component community, and occasionally the W3C issues. I definitely spout subjectivity on a regular basis, but it doesn't mean that I don't try and be objective. Those of you who haven't checked it out, it's similar to React, but on top of web components. Yeah, give it a check. I also use React on a daily basis, and I actually really enjoy it. It's a great tool, and I've obtained an invaluable amount of knowledge from using it and reading the code and participating a little bit in that community as well. But I still have my reasons for preferring web components as a platform. I think it's quite common for some of us to find something we like and stick with it. Using familiar tools helps make us efficient. That's not to say that we would make the effort to broaden our experience, that it wouldn't help us become better programmers, even if the result is that we stick with the same tools. No, that was unexpected. I'm sorry about that. All right. So let's fix this. So I'm just going to talk about kind of the background about the other product that I worked on and how Skate kind of came about, and then I'll move on to what's happened today and what's going on in the future for us. So I had originally written the Skate in the early days of the web component spec, toward the beginning of 2014. It was in response to some spikes that we were doing to trying to find a better architecture to start moving our components to. Skate now to Skate in 2014 is black and white, worlds apart. Components started vandalizing by the team. I've tried to figure out why, but we never made much progress. But it's hard to pinpoint what caused it. I often think it was due to analysis paralysis and the sheer amount of problems that we had to solve, situations we had to account for, and number of stakeholders the project had. The instability of the spec, the lack of browser support, and the size and performance issues that plagued the V0 polyfills compounded that problem. About 2 years later, we were given a clean slate to work on a new project. Similar to our old project, and to put our old project into maintenance mode. The goal was to build UI components to share across our product range with more focused goals and an emphasis on dev speed. Alongside this, React had been picking up a lot of steam internally. Most products were starting to use it in some way, shape, or form. In parallel, web components were reaching spec stability, and browsers began implementing the most important parts, custom elements, and shadow DOM. Sorry, just need to. It was a pivotal point for us because we could push the web components and follow the spec without being held back by our legacy products. It made a lot of sense due to spec stability and pending browser adoption. On top of that, web components offer not only cross-product, but also cross-framework compatibility due to shadow DOM, adding mutation details and external mutations. And this is imperative for integrating with virtual DOM libraries like React. This is particularly important to our team because we wanted for anyone to be able to consume our components, not just the part. It was either that or force other parts to be built in React, and that's not necessarily a bad thing, but probably not the best use of time. Being able to leverage the platform means several things. You get specs, native performance, and that built-in behavior that you don't have to send down the wire to the user. Another big thing for us was not having to move at the speed of the slowest product, meaning we'd probably end up having to support the lowest React version of our products while maintaining compatibility or aligning versions with other products. This keeps happening. I'm just fixing my slides. So fast forward a few months, we've built out around 50 web components, all written in Skate. There were some learning barriers, but Skate is a lot like React. It was easier to pick up for devs familiar with React than it would be with something else. This was pre-Skate 1.0, and we had anticipated some friction getting it to 1.0. And for the time investment to slow down sometime shortly after that. This part went mostly as expected. There was quite a bit of effort on my part getting Skate 1.0 across the line, and a bit of effort from myself and a couple other devs bringing it past that. But a lot of it, I'm happy for that. But yeah, looking back, it went mostly as expected. So it went from about 1.0 to 3.0, major versions, fairly quickly, as there were some unanticipated changes in the specs. And we decided that was best to convey through semvert, even though they might be unlikely to affect the consumer. So I want to start off by saying that I'm not really trying to call anyone out here. Browser and polyfill vendors are doing an amazing job at what they do, and I truly appreciate the contributions. Huge respect. But one big issue we were still facing is bugs in our own shadowed on polyfill that we were maintaining. We started this effort prior to Google building out their V1 polyfill because we needed a solution at the time, and we had our reasons for not picking up the V0 polyfills. We had almost 1,000 tests that were all passing, but when you drop them into a huge product with a lot of imperative DOM code and jQuery code, parts still broke. We spent some time trying to fix these and decided that we'd try the official polyfills, as Google had done a significant amount of work on them since we had started our own. It turns out they didn't improve the situation much, but they were moving quicker than we could maintain ours, so we decided to use them instead. Native custom elements posed a few trivial bugs with Skate, but nothing major. We fixed them and moved on. The biggest issue that we had was when Safari released their V1 Shadow DOM implementation. It broke our world. We had content, but it looked like someone threw in a CSS reset with Times Native, and we were doing everything right by the books. So what went wrong? After a bit of debugging, it turned out that if you created and set the content of a style tag imperatively, but the styles wouldn't recalc. So if you go document.create element style of text content, you give it to your styles, it wouldn't recalc on the second time. And this is an issue if you inner HTML the template to your shadow root. So that's fine. But we were using incremental DOM, which is a virtual DOM library, also written by Google. It's really cool. You should check it out. To render our templates to our components. And underneath the hood, it uses the imperative API to patch the DOM. So that gave us some problems. I want to emphasize the fact that an issue was found and raised while Safari was still in tech preview, and it was still released stable without a fix in sight until the next update to macOS. And I get that things happen, and sometimes issues slip through the cracks, but this ended up being the straw for us. We were completely helpless. What would have happened if in another 6 months down the road we were flying along in production and Firefox did the same exact thing? Even though it's a bug in Firefox, the customer is going to come knocking down our door, not Mozilla's. We had to pull the plug. I was beside myself. I had poured my heart and soul into Skate and web components, and there was a lot of time invested by other people, but it just wasn't enough. There was nothing we could do. I had to look at this more objectively. Now, looking back, I've had to ask myself, were the outcomes in a way to make either solution appear a better fit than they actually were? I've talked to others about this, and we feel Skate was still the best choice. They give us fantastic developer ergonomics and performance in a really tiny package. They exported a raw web component. Though I am undeniably biased, the decision was objectively informed by several parties. Looking back on the web component decision is really, really tricky. Over time, we acquired new information, and the criteria changed slightly. All involved parties agree that we made the most objective decision possible at the time. However, when revisiting the rationale with new information and updated criteria, React won by a wider margin than web components for the first time around. So what went wrong? So I want to actually go back a slide because I think I skipped one and talk about decision matrices. This is when I was having slide trouble. So Earlier when I was talking about web components and we were making that decision, they seemed really perfect on paper, but we had to justify why we thought it was the best choice for us. And we used a decision matrix for this. And the decision matrix is a method to systematically identify and rate the performance of relationships between sets of values. We ended up doing a decision matrix for React versus web components, and then another one for Skate versus Polymer versus Xtext. Web components won by a modest margin, but Skate won hands down. The bias towards both those, right? Which is, true. But I was also the one who had the deepest knowledge of the web component spec and web components in general, and the supporting libraries surrounding them. Other people involved in the decision-making process helped keep my bias in check by fact-checking information and asking some pretty tough questions along the way, which was really, really good, and good for myself too. So decision matrix, like you see this picture here, and you have criteria across the top and strategies across the left. And in this one, it's somebody trying to figure out the best care for the mother. And the criteria across the top is things that they need to solve with the possible strategies. And the strategy on the left is how they get there. The little numbers underneath the, I'll try and move my mouse here, underneath the criteria are called weights. So there's a 10 here, 7 here, and so forth. And for each cell and strategy for each criteria, you have 2 numbers inside each cell. The smaller number is the score that strategy gets for a particular criteria. And the bigger number is that score multiplied by the weight. And you do this for every single cell. And then you get your totals here on the right. And the totals give a good indication of what the best choice might be out of any set of choices on the matrix. So this is what we did for both web components and the libraries around them. Now I'm just going to skip past this to where I was. So if we could have a moment of bias, I think we all really wanted web components to win. All evidence suggests that they were the right tool for the job. And paving new ground with leading tech is fun and inspiring. Pragmatism suggested otherwise. And I think the objectivity weighed heavily on morale, regardless of what is right or wrong in the long term. And it was palpable. What's great about a well-informed team, though, is they pick each other back up and dust each other off. You end up better off than before you fell. I'm very lucky to work with such a diverse and intelligent bunch of people. I'm well and truly a better person because of that. So Skate ended up being a godsend here because it's a lot like React. Even though we didn't have to, we were already using JSX. This made using the existing component structure a breeze. And while some things ended up having to change a little, this made the transition simpler because we didn't need to move everything around. They thought about trying to use the shady CSS polyfills just before revisiting the tech stack. But right up until that point, we were largely using the standard Webpack style loader and CSS modules. In a couple of components, we were spiking CSS and JS with solutions like Glamour and JSS, maybe Aphrodite. Either way, refactoring styles mostly involved using a shadow-specific CSS. And though there was a bit more to them, React children are a lot like the slot element in Shadow DOM. Refactoring here was mostly just renaming slot to this .pop subchildren. And it's at this point you might be wondering why I'm giving this talk to a web component conference where you'd expect to see technical talks espousing the benefits of web components, as opposed to the caveats and hardships. And I'm such a web component fanboy, it's not even funny, so the pitchforks can go down. The reason I want to do this talk is there's so much that we can learn and do better at if we look at past experiences objectively and are empathetic to alternate points of view. This is a more abstract lesson that we can apply to most social and political ideologies, but let's look at it in the context of web components now. Web components were first introduced by Alex Russell at the Frontiers Conference in 2011. That's roughly 6 years ago. In that time, a lot has happened. Google released Polymer in 2014. later released 1.0 and are now pushing 2.0. React, Preact, Vue, Chew, Riot, Mithril, and probably hundreds more have all been released and are like web components, but not built on top of the standards. If I could take a guess as to why, I'd say it's close to the same reasons that React eventually became the chosen platform for our components. Another issue is that some seem to conflate Polymer and web components together. Rather than seeing it as a library built on top of the specs, some thought it was the web component implementation. This may have caused some to look the other direction if they didn't like the opinions of Polymer, because they clearly explained this at several points in their docs. But there wasn't much else to choose from, and not everyone comprehensively reads docs. One of the biggest reasons I feel web components lost steam, though, is the amount of time it's taken for the specs to reach stability. There's many reasons for this, and I fully understand that some things need to be hashed out, but at the end of the day, we want to build stuff, and developers are going to choose what makes them productive, regardless of whether or not it's web components. Personally, I don't care if it's create shadow root or attach shadow. I really just want to be able to use shadow. And overall, a lot of these changes were necessary and very positive, but I feel the W3C working group for web components needs to take the community and those who provide feedback a little bit more seriously, and to also learn from what's happening around them in other communities. I fully empathize with the fact that the lack of browser agreement and important issues has not helped this process. The lack of compromise on their part has possibly been one of the most impactful problems that has hamstrung web components. We need to try and look at the bigger picture as a whole rather than encapsulating ourselves into a bubble. As I've stated before, I'm not trying to pick on anyone or any group in particular. However, if we don't call these things out, how can we ever improve? Realizing shortcomings isn't easy, and it's something that even the best of us struggle with. But we can only become better if we know what to improve on. Though it's been a slog, we're almost there. And I'm not talking about this talk, I'm talking about web components. The future is indeed bright, and there are many benefits that we can and should count on. Framework agnostic UI components has always been the sales pitch, and the elephant only scratching the surface. Instead of relying on Polymer or Skate to provide abstractions, what if you could use a Vue component inside of a React component, or vice versa, just by writing HTML? With tree shaking, size becomes less of an issue. If you build on top of the platform and embrace the constraints, which means just write HTML, this is entirely possible. The politics of this is more complicated because it's harder to lock developers into your framework as a platform. But we need to start realizing that the web is more than just the number of stars you have on GitHub. Longevity. For as much shade as I threw toward the spec earlier, I think it's probably the largest contributor to the web being the most democratic, popular, long-lived, and stable platform that we have ever had the privilege to build on top of. And let's face it, if we can change the lifecycle callback names like 4 times, we're pretty privileged. Performance. When you register a custom element, you're handing off so many things you'd have to do at the framework or library level to the browser. In doing this, your element lifecycle is closer to the metal, and as a byproduct, we don't have to reinvent that, which leads me to my next point, productivity. If we're not reinventing the core component lifecycle and optimizing things that the browser already does well, we can spend time on other things, like actually building components. We can even build abstractions, like Skate and Polymer, on top of the platform and feed back the relevant parts of the spec, iteratively from the web at the platform over time. Web fusion. A number of questions and issues in Skate and other forums have popped up that I'd like to run through. Developers still seem fairly confused in the best way to style components. A question I've heard many ask is, isn't this going to be slow if I render one style tag for every component? I haven't experienced this firsthand, and I remember Rob Dodson saying something about how browsers will optimize this internally, but it still seems that there's no official stance on the best practice around this. There is also no straightforward way to integrate existing CSS frameworks like Foundation or Bootstrap. The best solution I could find is to include the parts you need, but there's a little bit of friction around that. And sometimes you end up including most of it anyways. The most robust method is to include the whole thing in every style tag. Going back to the previous question isn't that bad. It feels bad. Another issue I see a lot is when you try and build something like a custom select component and you have children that represent custom options. The slots work great for projecting content, and then there's the slot change event, but that doesn't get fired for the children that are already there when the component is upgraded. And working out exactly what to do when it does change isn't exactly clear. The other side to this is if you have no slots, but you still need to act on child content, how do you observe changes to that content? Many of us will immediately turn to mutation observers. Some are scarred from mutation events and will question if that's the right choice. And it's actually a very common problem to do something like that. I encounter it in many components that I build, including these slides. I built this slide deck in web components, but I'll go into that later. So one of the other problems is, and it's a really common question I get in Skate, it's how to turn off rendering to a shadow root, because we do that by default. And it can be for several reasons. One reason is for simpler styling, because selectors become fair game. But legitimately, many seemed very concerned about accessibility in web crawlers indexing the content. I don't have a good answer for this, but one thing is for sure, that for seamless integration with other frameworks that control child content of your elements and other things, you must absolutely hide your implementation details from them. So turning off Shadow DOM shouldn't be the answer we give them. A shortcoming we've experienced firsthand is when building custom form elements. If you put a form inside of a shadow root, the value never gets, a form element actually, to be clear, inside of a shadow root, the value never gets serialized when the parent form is submitted. Additionally, if you put a submit button inside of a shadow root, they don't cause the form to submit when they're clicked. There's proposals for solving these things, but nothing concrete has been worked out yet. Luckily, there's workarounds, but it means rebuilding that behavior. Employs some form of pitting them against a framework or library. Comparing a low-level API to several levels of abstraction is not really constructive. Regardless of whether or not it was done intentionally to frame web components as inferior, we need to do a better job of educating people and find better ways to do this about web components. I've seen several high-profile people in other framework communities spreading this information about web components in the past. And many of these have been addressed in a great post that Daniel Buckner wrote. So I'm not going to go into exactly what they were, but it's necessary to point out that this struggle, web components are going to continue to experience it for quite some time due to the lingering effects of uninformed bias and biased arguments. So what's the moral of this story? It's impossible to do 100% of the time, but we need to try and remove our biases because it will help make decisions more objective and discussions more productive. Empathy is a very useful tool. Despite the allegiances that we hold, we need to take a step back and focus on the bigger picture. It's not about being the winner of a popularity contest, but it's about making the web a better place for everyone. And last, the best way to overcome the problems that our communities face is through education, objectivity, and empathy. Let's solve problems together. Thank you.
Thank you, Trey. The amount of research you put into that talk was outstanding, and it's really good you can spend time and tackle such an important thing in our community. So thank you ever so much for that. And thank you once again for taking the time, staying up and delivering that for us. Thank you ever so much. And for everybody else, we'll be moving on to the next session in just a few ticks. So see you shortly. Thank you again, Trey.
Cheers.